Fall Probe 1, 21 through 25. Okay, question 21. So, if you read this question, you know the train is traveling 60 miles per hour, sound is 70 miles per hour, but the train is right there, and it honks the horn when it's 4 miles away from the structure, right? And the train's gonna keep moving, then the structure is gonna bounce the sound back, and it's gonna continue. And then at some time later, um, they're gonna meet. And the question is how many seconds until the train hears the sound. So if we want to think about the starting point, um, the starting point is when the train honks its horn. Okay, and so the sound is gonna have to travel back 4 miles, and then bounce, and then 4 more miles until it even reaches the starting position of the train and start heading in that correct direction. So that's gonna be 8 miles, right? 8 extra miles for the sound to travel at 700 miles per hour, right? And the train is going 60 miles per hour, but it's got an 8 mile head start, right? So if we measure in hours because it's miles per hour, then this would be something like 60t plus 8 because we've got a 8 mile head start, right? This is how many miles the train will travel after t um after t hours from this, or I guess in this situation that we've constructed, not in actual reality. It's just a convenient way for us to model because it's the same as if the sound was from some other horn that was 8 miles away, right? It's the same exact scenario, and this is just treating this confusing scenario where we have bouncing as the less confusing scenario where we don't, and they're both going in the same direction from the start. So we would say 60t plus 8 in this situation is how far the train is from the sound at time t, or how far it is from the starting point of the noise. And then the noise's distance from the starting point is going to be 700t, right? And so if we want the two of these to meet at time t, then we're going to set these equal to each other. So then 8 would be 640t, okay? Then we divide by 8, we get 1 equals 80t. But then you might realize, well, what's going on here? All of our answers are like 40 seconds, 42 seconds, 45 seconds. Like this is nothing. We're going to get t equals 1 over 80, but t is in hours, which is 3600 seconds, right? So if we say that we have 1/80th equaling t, then really in seconds, this is t in hours. If we want to get that to seconds, we would have to multiply by 3600. Okay, so we would end up with 3600 over 80, which is 36, or 360 over 8, which is equal to 45. So our answer is C, 45 seconds. Okay, question 22. What is the coefficient of x, y, z cubed in the polynomial x plus y plus z all to the fifth? Okay, so if you know how to expand a polynomial, then you should know what the answer is gonna look like. It's gonna look like you have x plus y plus z to the fifth equals, like, I don't know, something x to the fifth plus something like y to the fifth plus something z to the fifth plus x to the fourth y multiplied by something. We don't know. So it's going to be all those different terms, right? So we're going to have x, y, z, all to different powers, a, b, and c, right? In all these situations. And they're always going to add up to 5. And B is allowed, A, B, and C are allowed to be 0, 1, 2, 3, 4 or 5. So in this one, it'd be like a equals 5, b equals 0, c equals 0, and that's how you get that. But it's whatever the coefficient, like this question mark I have written there, that's how many times we're going to be able to multiply it out. So we actually do know what that question mark is for the x to the 5th, y to the 5th, and z to the 5th terms, because if you want to get all 5 x's, right, then you're going to have to take an x from each one. And there's only one way to do that, right? But if you want to get x to the 4th y, then you can take you're like assuming that you're starting with all x's, and then you're taking the y from 5 different possible factors, right? Because there are 5 different factors of x plus y plus z that you could take the y from. And that would give you a coefficient of 5. And so any of the ones where it's like x to the 4th y or x to the 4th z, whatever the letter is, if it's like interchanged or whatever, it doesn't matter. It could be z to the 4th x, and the coefficient would still be 5 on every one of these things, because you're assuming you're starting with whatever the thing to the 4th power is, but then replacing it, and you've got 5 different options to do that. What if we looked at the z cubed xyz term? Well, we know it's going to be the same as the x cubed yz term, for the same reason as why you can exchange these with each other. It doesn't really matter, right? It's just what we're calling them. I mean, if this was y plus x plus z, or z plus x plus y, nothing would change. It would still come out to the same thing. And so that's why, as long as the as long as a, b, or c all match one of these, like in this situation right here, all match, then it's going to have the same coefficient. So what could we do? We have three z's, right? Z, z, z. Right. What if we assume we start with 5 z's, like we did assume we start with 5 x's here, but then we need to replace one of them with x and one of them with y. Okay, so there are 5 z's, and we replace one of them with x. Now we have x and then 4 z's, right? But we have 4 ways to replace a z with a y, right? So we could have x, y, z cubed in 4 times more ways. So there'd be 5 options for replacing the z with the x, right? And then there would be 4 options with replacing the remaining z's with the y. So it'd be 5 times 4, which would be 20. So the answer is B. Okay, question 23. Question 23 is a lot like one of the questions from earlier. I don't remember exactly what it was, but it was like you have 110 planks, and then Bob is going back 4, and then Alice is going up 3 or something. How many do they like overlap? And the reason it's the same is because it's the same technique with modular arithmetic, just a little slightly more complicated. So an integer n is said to be sandwiched between n minus 1 and n plus 1 if n minus 1 and n plus 1 are either a multiple of 5 or a multiple of 7. So it's between a multiple of 5 and a multiple of 7. So like 5, 6, 7. 6 is between 5 and 7, right? So that would work. 28, 29, 30, 29 would be between a multiple of 7 and a multiple of 5, so that also works. And it's asking how many of those there are. Okay, so we want n to satisfy here. Let's break this up into different cases. First, let's look at when n minus 1 is a multiple of 5. So if you remember modular arithmetic from before, n minus 1 is congruent to 0 mod 5, which just means it has remainder 0 when divided by 5. Okay, so that means that n would be remainder 1 when divided by 5. Okay, so n is congruent to 1 mod 5. Okay, so we can write n as n equals 5k plus 1. Okay, and then k can be like 1 or 2 or whatever, right? Okay, cool. And then we also know that n plus 1 is congruent to 0 mod 7. Okay? And then notice that if we ever have a multiple of 7 and we add it to something in this situation right here, then that's going to be the same as adding 0, right? Because anything that's a multiple of 7 mod 7 is 0, right? So if we add 6 to both sides, right, then we're going to get n plus 7 is congruent to 6 mod 7. Okay? And so that means this 7 right here is congruent to 0 mod 7. So that would leave just n being congruent to 6 mod 7, right? That remainder has to come from n. The remainder of 6 has to come from n because we get a remainder of 0 from the 7. So it just goes away. Just get rid of it. Okay. So we know these two things about n. We know that n equals 5k plus 1, and that n is congruent to 6 mod 7. Okay, so that means that 5k plus 1, if we replace n here, is congruent to 6 mod 7. Okay, and then let's subtract this 1, right? So 5k is congruent to 5 mod 7. Notice that 5 and 7 are relatively prime, so we can divide by 5 mod 7. So we get k is congruent to 1 mod 7. But n is not congruent to 1 mod 7. N is congruent to 1 mod 5. Okay? So we would write k equals 7t plus 1. And then we'd go back to n that we had before, right? N equals 5k plus 1, and write n equals 5, replace the k, 7t plus 1 to give us 35t plus 6, right? And so if t is 0, that's how we got the 6 from before, right? Because remember, 5, 6, 7 worked, where 6 was wedged between 5 and 7. But now it's saying that if t is just an integer, right, and n is within 1 and 100, then if it looks like that, then it's going to be sandwiched between a multiple of 5 and a multiple of 7. And that makes sense, right? Because 6 works. And then we're going up in this like little triad that we have going on right here. We're going up 35, right? So this number is going to become 40. This is going to become 41, and this is going to become 42. Now this stayed a multiple of 7, this stayed a multiple of 5, because 35 is a multiple of 5 and of 7. So if we add it to 5 or 7, then we're not going to change whether 5 or 7 is a multiple of 5 or 7, right? So that's where that comes from. Now we found 29 before, but we didn't need to just come up with that, right? Because we don't need to come up with 6 here. We just plug in t equals 0, right? Okay. So now we know that it can be of the form 35t plus 6, right? We know that n can be of that form. And we're going to count how many of those there are, but not yet. Let's just find the other case. N minus 1 is congruent to 0 mod 7, which would mean that n equals 7k plus 1. But then we're going to plug this into our other restriction, which is n plus 1 being congruent to 0 mod 5. Okay, so then n plus 5 would be congruent to 4 mod 5. And then n would be congruent to 4 mod 5. And there might be some of you who are saying, why not just make the 0 a 5 and then subtract 1 from that, right? Subtract 1 from both sides. That's what I would usually do. But I'm just trying to communicate the idea that whenever you have a multiple of k, mod k, then that term goes away, because it's always divisible by k, so it doesn't leave a remainder. So that's why we can turn it into 0. Okay, so n is congruent to 4 mod 5. That means that 7k plus 1 is congruent to 4 mod 5. And then 7k would be congruent to 3 mod 5. Now, what's a multiple of 7 that's one more than a multiple of 5? Not 14, 21. Okay, how do we get to 21? Is we multiply 7 by 3. So that will give us 1 mod 5. Okay, so if we multiply this by 3 and this by 3, then we get 21k is congruent to 9 mod 5. But now we reduce these by subtracting however many multiples of 5 we can, right? And we can subtract 20k mod 5 and 4. And 5. So we would get k is congruent to 4 mod 5. And then if we go back over here, then we get 7k plus 1 equals 7 times 5t plus 4 plus 1, which gives us 35 plus 29. 35t plus 29. Okay, so it's either in the form 35t plus 29 or 35t plus 6. And we want to count how many of those there are. So t can be, let's just go right here. Let's say t equals 0. That gives us our first term that works, which is 6, right? And then t could be 1, 2, 3, 4. And when would it stop? When would we get above 200, right? So if t was 6, then 35 times 6 would be 210, right? So t has to be less than 6. So, because 210 is already too much. So let's say t equals 5. Does that work? T equals 5, then 35t would equal 150 plus 25, 175. But then we have to add 6 here, so we'd be at 181, which is obviously less than 200. So we can go up to 5 for t in this case. So we have 6 total. This case gives us 6 total. Okay. All right. This case, t again can be 0, right? And that gives us 29. So t equals 0. But then again, maybe let's try 5 again, because we knew 6 was going to be too much no matter what we add, right? So let's try 5 again. We get 175 plus 29 this time, which is greater than 200. It's equal to 204, right? So that we know that it has to be up to 4 this time, right? 0, 1, 2. I don't know why I'm putting dots there. I could just put a 3. 0, 1, 2, 3, or 4. And that gives us 5 total in this case. So all in all, we've got these 5 cases and these 6 cases together. Boom. 11 cases. So that's our answer. Question 24. U, v, w, x, and y are integers from 1 to 9 inclusive. U plus v equals w, and w plus x equals 10y plus u. What is v plus x? Okay. So if we replace w with u plus v, right? Because that's the information we have. So let's plug it in. It looks like we have too many variables here, but maybe let's just get rid of this one, right? We can eliminate w. So then u plus v plus x equals 10y plus u, and then the u we can just subtract away, right? So then we've got v plus x equals 10y, and this is kind of funny because v plus x are between 1 and 9, okay? So then v plus x can be no greater than 18, right? And that would be if v and x are both at their maximum at 9, right? So we know that 10y is less than 20, right? So then obviously 10y would have to be 10 because there are no other multiples of 5, right, that 10y could be, or multiples of 10 that 10y could be, because it's less than 20. It can't be 0 because it's between 1 and 9. But it's also funny because v plus x is a multiple of 10, and there's only one multiple of 10 listed among the answer choices, so it has to be d. So those are two ways that you could figure out that it's d, but yeah. Okay, question 25. A square with side length 1 is placed inside a square with side length 5/4. We then cut out two isosceles right triangles of leg length x from the top corners of the smaller square. What is the smallest possible value of x so that after cutting, the smaller square can be rotated by an angle without leaving the bigger square? Okay, can be rotated by any angle without leaving the bigger square. So we can like rotate it as much as we want without it like getting stuck, right? So what we don't want is for it to get stuck like on its longest side, like this. It looks like after we cut this off, this is going to be the longest length in it. We don't want it to catch against the walls of the 5/4 by 5/4, right? So we want it to fit like that and not like this. Okay, so if what we want is for this length to not get caught, then all we need is to make sure that this length is less than 5/4, right? Because that's that length right there, okay? So we want to cut it enough so that there's never going to be a length that we can draw inside this shape greater than 5/4. And no matter what you do to this, the longest length that you can draw is going to be one of these, right? And they're all the same length, right? From an opposing corner to one of the newly made corners, right? Okay, so if we set that exactly equal to 5/5, if we set that exactly equal to 5/4, then we would have a right triangle with side lengths 1, hypotenuse 5/4, and other leg would be that's x right there, and this whole thing is 1, so this is 1 minus x. Okay, so we need 1 squared plus 1 minus x squared to be equal to 5/4 squared. Okay, so then 1 minus x squared equals 25 over 16 minus 1, which is 9 over 16. So then 1 minus x squared equals 9 over 16. That means 1 minus x equals 3/4. So then x equals 1/4. There we go. That's our answer. Okay, so that wraps up the 2025 Fall Probe 1. This is a kind of a tricky one. I would say this one was pretty hard. This one was a little bit tricky, but overall, pretty doable test. Thank you for watching.